Welcome back, students. This is the Q&A session 24 from the playlist of JEE Physics. The chapter is current electricity, and for this session, I have taken this question, which is written on this board. The question here is: there are two concentric spheres of radius a and b, respectively. If the space between them is filled with a medium of resistivity rho, then the resistance of the intergap is. So there are four options here, and we have to find the correct one. So in order to save the time, I have already drawn these two concentric spheres here on this board, and I have also drawn one concentric sphere in the intergap, that is in the gap between these two spheres, and I have depicted these two spheres by A and B. The inner one is A and the outer one is B. Now the radius of this inner one is A, the radius of the outer sphere is B, and I have taken one concentric sphere of radius x having the thickness of dx, which is lying in the gap between the sphere A and B. So we know that the resistance is given by rho divided by rho into L divided by A, where rho is the resistivity of the conductor, L is the length of the conductor, and A is the cross-sectional area. So using this relation or using this equation, we will be solving this question in order to find the resistance of the intergap. So let us here I have this is uh, the concentric sphere with a dotted line, which I have considered between the two spheres, that is A and B. This is the gap between the two concentric spheres, and I have considered one concentric sphere of radius x having a thickness of dx, which is lying in this gap. So the resistance of this concentric sphere of radius x can be written as dr rho dx upon A. Now the surface area of a sphere is equal to, if there is a sphere here, it is having a radius say r, then the surface area of the sphere is equal to 4 pi r square. So in this case, we will be writing A will be equal to 4 pi x square, because the radius which I have considered is equal to x. Now in order to find the total resistance of this intergap, that is the gap between the sphere this A and B, we have to simply integrate this equation, and the limits for this integration will be from A to B, because we have to find the total resistance of the this gap between the sphere A and B. This is the gap, so the limits for integration will be from A to B. So now here what we can do is that this integration, this will be equal to r. Rho is a constant, so I will be taking it out, and rho upon 4 pi is a constant, and this will be equal to A B 1 upon x square dx. So now this equation can be written as, it implies that r is equal to rho upon 4 pi. The integration of this, that is equal to from A to B, and this will be equal to x to the power minus 2 dx. Okay, I have taken this x square in the numerator. So now this r will be equal to rho upon 4 pi and if I integrate this one, I will be getting as x that is equal to minus 1 by x a to b. And now this equation can be written as r will be equal to rho upon 4 pi. I will be putting this value, the value of this x as b, so I will be getting as minus 1 by b minus bracket minus 1 by a. So r is equal to rho upon 4 pi, that will be equal to 1 upon a minus 1 upon b. So the resistance of the this intergap will be equal to rho divided by 4 pi, and in bracket 1 divided by a minus 1 divided by b. So this is how we have to solve this question here. Now the only thing in the most important thing here which we have to remember here is that the resistance R is equal to rho L by A. You have to use this formula. And then second thing is that since we have to find the resistance of this intergap, so you have to consider one concentric sphere of say radius x, as I have considered in this equation, having a thickness of dx. And so using this formula we were able to find the resistance due to this differential element, or you can say this differential concentric sphere, that is equal to, will be given by dr will be equal to rho dx upon 4 pi x square. So by integrating this equation we were able to get the value of the resistance of this intergap, which is equal to rho divided by 4 pi in bracket 1 divided by a minus 1 divided by b. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question from the same chapter, that is current electricity. So till then, have a nice day. Bye.